Hello, everybody. My name is Angelin, and it is so much pleasure for us to have Professor Mike Yao with us here. Um, Yao personally is my old friend. We have known each other for, how many years? 20 years? Must be, yeah, since we both were at the City University of Hong Kong in the 2000s. And Professor Mike Yao is the founder of the Illinois Media Technology and Social Behavior Lab, where his research group explores the dynamic interplay between media, technology, society, and human communication. They investigate how individuals engage with emerging technologies such as AI, VR, AR, and mixed reality, MR, and how these interactions influence behavior and social outcomes in digitally mediated environments. Dr. Mai Yao holds a joint appointment as Professor of Business Administration in the Guy's College of Business with affiliate appointments in the Department of Communication, School of Information Sciences, and the Cary, Illinois College of Medicine. He's the associate editor of the Journal of Computer Mediated Communication, JCMC, and a flagship journal of the field, ranked 6 out of 227 journals. So I've been reading out from the bio, but I just had a lunch conversation with Professor Yao, and I felt that I've learned so much just from talking to him over lunch and giving me so many fresh insights and perspectives. So without further ado, let's put our hands together to welcome Professor Mike Yao.
Thank you, Professor Lin. Thank you, Andrew. Thank you. All right, can you hear me okay? All right. It's truly a pleasure. I feel like it's homecoming. I left Hong Kong about 10 years ago, but I did spend 10 years working at City University. So everything is so just coming back to Hong Kong and then feeling a bit nostalgic. And I can't believe it's been 20 years. So I really, my gratitude for Education University of Hong Kong and Professor Lin for inviting to spend a bit of time. It's rare that I have opportunity to get out of our usual work mode and to really come and start thinking about some of the bigger ideas in an environment that allows for this kind of intellectual exercise. So I'm very much looking forward to my visit, meeting many of you here when I'm, it's a relatively short visit, but I'm sure I'll meet with all of you, have great conversations. All right, so today I want to talk about a couple of things. It's really a big idea, a collection of studies, sometimes not knowing the specific audience and slightly out of context gives us the flexibility to present ideas that are not very mature. It's with that spirit I'm here to share some of the ongoing work and thinking, because everything we're dealing with, particularly for those of us who have studied technology in the last 20, 30 years, the speed at which the new technology is being developed outside of the academic environment really force us to kind of take a very different perspective. On the one hand, our theoretical, empirical research has a longer arc. We ought to do research that generates knowledge that's beyond tomorrow, beyond next week. We need to think about next 30 years, next 50 years. When we publish paper, we need to think about whether my paper would be still relevant 50 years from today, right? That's our mission. But at the same time, the speed at which we are dealing with these new technologies as users themselves, particularly in social and behavioral sciences, that we are both researchers of the technology, but also as the users of the technology. Presents a lot of issues from at the empirical level, theoretical level, philosophical level. And it makes our work all that important, but also we need to pause and start thinking about some questions. And then Professor Ling talked about our lunch conversation, as I mentioned to Professor Lin during lunch, I see my work just last 7, 8 years has become so interdisciplinary. It forced me to become almost an amateur philosopher, really to put that doctor of philosophy to work, because then to have to remind myself that I have a degree, the advanced degrees in philosophy. Ultimately, where we go is this, right? So I start thinking, listing all the affiliations as a symptom of the kind of society we're living in. And so I want to start with a brief introduction of about self, not really about me, but about my intellectual journey. Why I end up being affiliated with, from College of Business to medicine to media to communication to entrepreneurship and on campus and overseeing some startup companies and doing all kinds of work. Of course, there's a personality flaw, but at the same time, it's really a reflection of the kinds of technological environment we are facing today. And after that, I'm going to move forward to talk about the framework of today's talk, which is how do we think about AI at the ontological level, not at a specific theoretical level, but we go back to say, not only is AI, that's the question all of us are dealing with right now, but what is AI to us? Why should we care about AI as researchers and as users, to really explore the ontological nature of human AI relationship? And then if the time permits, I'm going to present some of the ongoing projects as a way to share some ideas. And then I'm happy to answer some questions, right? So looking forward to this. So very quick introduction to anchor my intellectual roots. My intellectual roots, I started studying a combination of humanities and cognitive science. So from the very beginning, it's sort of my interest in media and psychology allowed me to combine my interests to pursue a graduate study in communication and cognitive science, but specifically looking at media psychology. So 20 years ago, I would introduce myself as a media psychologist, right? But gradually, because at that time my research really fell into my home discipline is what we would call the computer-mediated communication, which was an emerging field in 1994. This journal was founded by ICA, International Communication Association, as a peripheral journal that nobody cared about. An online journal that nobody only publishes on the internet, dealing with how computer systems mediate human-to-human communication back in 1994. A very novel, marginal topic. Fast forward 30 years at this point, I don't need to explain to people what computer-mediated communication is. In fact, we had an identity crisis, right? So the journal a couple years ago was forced to evaluate what is not computer-mediated communication. So 1994, we had a tough time explaining to people what is computer-mediated communication. 30 years later, we have a tough time explaining what is not mediated, right? That's how fast things are happening. And we're seeing a similar trend happening in AI space. Okay, today, like sort of 5-10 years ago, for those of us who started researching AI as, in the context of computer-mediated communication, had to go to a conference, really explain to people, spend most of my talk explaining the kinds of algorithm and AI that we're dealing with. Overnight in 2022, when ChatGPT released its public version in November 2022, suddenly the challenge is every single one of you are users and experts and researchers of AI. Like our field just explodes with AI-related topics. So computer-mediated communication is my home field. Increasingly, my work deals with moving from how human to human communicate, using this screen as a technology to mediate the communication and the information system behind it. But the technology becomes a lot more front and center. So the direct interaction, we start to emerge and start publish and work with scholars that historically on the engineering side of things and computer side of things, which is how humans interact with technology interface. But increasingly, that problem has become more of a social science oriented, right? Engineers used to just design interface to allow you to where to click. But now with voice, with interaction, the interaction is a lot more complex. And insights about communicative processes, dialogues, conversations, how humans talk to computers become a core, moving from fringe to the center of HCI, or human-computer interaction. And then increasingly, I would say I'm identifying more and more with this newly emerging field of human-machine communication, replacing a couple of words. We know it's no longer accurate to keep calling it computers. Because what is not a computer? Your phone is a computer, the chip is a computer, everything, computers all around us. Right? Second, so we think that machine is a much better technological system, is a much broader concept. Communication, replacing the word interaction. Interaction is more purposeful. I'm interacting with computer to do a certain function. But communication has meaning, symbolic interaction. So we start to bring in insights about what we know about how communication works, meaning creation work, how not language, not just as language, but language, the meaning behind language becomes more important than the language themselves. So it's based on that, I want to start today's talk to talk about, I think our social science research currently is experiencing an identity crisis. Our lab, our group, I will introduce about our lab a little bit. We have recently took on a big challenge. We really wanted to know what the AI literature looked like in the last 10 years. So what we did, we started collecting two data sets. One is the broader SSCI, entire SSCI universe of looking at how social behavioral sciences consider social science study AI in the last 10 years. So we're dealing with about 15,000 articles at this point. We're training a model and then learning topical and trying to analyze big data. We extracted a couple hundred of core articles from the communication, the field of communication, trying to understand how AI. But the long story short is the term AI was a very specialized term 5 years ago, right? I studied AI. We call it algorithm, AI agents, virtual agents. We study AI as a specific, context-specific construct or phenomena within our each of domain. So you have AI research in language, you have AI research in media, you have AI research in communication. But the term of AI, we don't need to explain to people because within the specific research context, we know what it is. So I publish in JCMC or human behavior, computer and human behavior. When we say AI to the reviewers, to this particular field, AI carries a specific meaning. Right? We don't need to explain it. What happens, talking about language use, is after 2022, AI has moved from a theoretical construct or a specific research topic into the domain of public discourse. Now my mom's talking about AI. Now my son is talking about AI, range from 2-year-old to 100-year-old talking about AI. Suddenly, when you start to look at papers published in the last 3 years, we see a trend. Nobody bothered to define what AI is anymore. Nobody to say, in the same paper, we start to see an introduction section, AI is everywhere. And then we're gonna move to a theory to study one specific instance of AI, and then we're gonna draw conclusions about AI all like broadly, right? So this is not a criticism of our field, but I think it's because as users, when it's something novel comes out, we're fascinated by it. We're users, we don't know what to do with it. So we start thinking, okay, large language model, vector space, computation, deep neural learning. But at the end of the day, I think what we're doing is we start to focus too much on the technical aspect of it, start not to think about AI. I would like to change the discourse in social research to ask not what is AI, that's engineers' problem, that's computer science's problem. I'm not in the business to develop a large language model. Right? I do work with my colleague, a very good friend of mine, who is in the business of developing large language. I do work with mathematicians who are training data sets and then doing specific AI-related work, very advanced sci-fi stuff. But what I do, I don't study AI as an engineer or computer science. I have to think about what is AI to me? Why is it meaningful to my research? So it is with that I really wanted to begin with a thought experiment. Okay, just for the time being. Imagine you are working on a task. You have a choice of having a human assistant and an AI assistant. On the side of the human assistant, nobody expects humans to be perfect. I would never, ever say, my research assistant gave me an imperfect answer, you're hallucinating. I would never use that term to call my research assistant's work as hallucination. Okay? Because I tolerate mistakes. I understand that when I'm collaborating with a human collaborator, we are human. You have limitations of your knowledge. They can't search the entire database. Their statistical model is going to have errors in it. Their coding may have errors in it. There are factual inaccuracies, right? We check their sources of paraphrase because I will not verbatim have my RA write something and I don't even bother to proofread it and then put in my paper and submit it. I will be the gatekeeper because that's my research, my publication. I'll edit it, I'll think about it, I'll work closely, and then I'm the gatekeeper, right? We appreciate the human effort. We contextualize their knowledge and say, oh, she must be tired. They must be tired. He must be happy when he wrote that. Oh, maybe he did not take that statistic class. That's why that particular model has that error in it. I add a lot of additional attribution and thinking to a human collaborator. When we work with our human collaborator, work style, personality differences, communication differences, we take all that into consideration when we form an overall impression and evaluation of a human partner. And then we build long-term trust through repeatedly working with this person and adjust our evaluation. Trustworthiness, credibility, reliability, dependency, professionalism. But at the same time, I'm using AI as a partner. I expect a one-shot success. I'm going to give you a command. You better produce the perfect article to me that I do not need to edit. I can submit it tomorrow and get an SSSCI publication out of it, right? I expect that your code will never make any errors. How dare you come back and then run some problem with the coding that doesn't work? We calling it hallucination instead of thinking about a limitation. So think about the way in which we use the language to evaluate AI systems, and then we evaluate systems. But essentially, we're asking them to do the same thing now. So with this question in mind, why do we extend such grace to humans but demand perfection from machines is a philosophical question, right? So let's think about the social dimension of technology. These are a couple of news articles that's news story that came out. So the first story, okay, big story came out. ChatGPT owner, the CEO, OpenAI CEO Sam Altman came out publicly saying that it's pointless to use word thank you and please when you interact with AI because it's wasting OpenAI, hey John, tens of millions of dollars just to process those tokens that actually does not affect any of the performance. But Sam Altman acknowledged that this is important because it makes the user feel happy and comfortable. We feel like we're collaborating. So it's worth the company to actually create a product that builds into the politeness and etiquette, social etiquette into it, even though it does not actually affect the performance. Oops, sorry, keep on pushing the wrong direction. A couple of weeks later, very ironic, another controversy happened. OpenAI had to come out and step back its model to remove the politeness a little bit. What happened is, here just in short, OpenAI has pulled back the latest update to ChatGPT 4.0 that made ChatGPT too sycophantic, which is too polite, too eager to please the human user. Keep on saying, you're the smartest person. Let's work on your ideas. That's a brilliant idea. Let's work on this. It went overboard. Users were not happy about that because now we're suddenly working with someone who's so eager to please us. And that became a problem. So OpenAI is addressing the issue by pulling back and saying that short-term feedback led ChatGPT's disingenuous behavior. What's in common? Just within a span a couple of weeks, right? On the one hand, it addresses the importance of a technical system to have human features, to make human users feel connected. At the same time, when it's going too far, it becomes creepy. We don't like that, okay? What's pointing out is that AI performance didn't change in both scenarios. AI is AI, it's doing its thing. What changed is our mind. We are changing. It's our mind frame, our mindset that brings into the human AI communication and collaboration. So what AI is to us is shaped by its social cues, not just its capabilities. So fundamentally, we are dealing with a social machine, not just a technical machine. That's based on that, we'll continue today's conversation. So very briefly, just in case, I'm going to walk through the next couple of slides very quickly. I don't intend to spend too much time, but I think it's interesting to kind of trace back and say, well, what is AI technically? Current versions of AI. I always wanted to remind all of my students when I do the teaching to let's not forget the root of AI is a multidisciplinary culmination. This is not computer science's magical thing in the last couple of years. This is more than half century of interdisciplinary research. It depends on over the 100 years of culmination of knowledge, research from multiple fields converge to this point that allow us to have the explosion of today's technology. Nobody should take credit for that. Nobody invented AI. This is a accumulation of hundreds of years of knowledge leading to this. But it's an explosion because suddenly it became a thing because now the performance is there. So the foundation is really computations, right? It's about program. I always like to point out the fact that the world's first computer programmer is a female, right? Let's talk about gender diversity. We don't acknowledge that diversity enough to say that the kind of way of thinking, it's about automating the idea of mathematically automating tasks. That gives basically the foundation of algorithm and computer programming language. And then Alan Turing, of course, more famous in the 1950s, started thinking about the concept of universal machine, introduced the idea. We all know the Turing test. But then there's a very important aspect, contribution is the cognitive psychology and neuroscience, understanding how human brains function. That body of knowledge gave the foundation to neural network. The word neural network is not a computer science term. It's actually a neuroscience and cognitive science term. Then all of that are conceptual. We already know how algorithm work, if the machine work. Finally, the advance in chips, computer engineering, storage, data accessibility, the hardware caught up, able to realize some of these ideas. But then there's the information. So then now you have the brain, you have the algorithm, you have the hardware. What's missing piece is data. So coincidentally, last 20, 30 years, it's an explosion of human input and social data because of internet. And that digital explosion of human-generated data transformed the scale and scope of machine learning to actually achieve this dream. So it's that culmination leading to AI, today's AI, right? So that's why I always add the parentheses, say today's AI, because it's changing every day. So very quickly, how today's AI understand, think like human in a very basic conceptual level, right? Explaining to non-engineer and so computer scientists. Natural language processing, you've heard that term before. It's about how machines read and process language. In this case, language is express language. Right? I always wanted to, even when I work with computer scientists, I always say that the limitation is what about nonverbals? What about things you can't see? What about all the subtle cultural cues that you can't not express? Natural language is about language defined as textual words, images, expressed things. So it's not a direct proxy for communication. But nevertheless, natural language processing is a field that focuses on using algorithm models that enable computers to understand, interpret, generate, and respond to human language in a way that's meaningful and useful. But here's the problem. Natural language existed way before current version of AI. What changed? What makes the current version of AI perform so much better than 1990s computational linguistics scholars working on a lot of things, 1980s? This natural language processing is a multiple decade, more nearly half century old. What happened? Well, here's the question I always ask, say, how do young children learn language differently from adults? Why is it so much easier for us to learn the first language? We don't need to go to school to learn grammar. None of you went to grammar school to learn Cantonese or Mandarin. But the second language we learn, it's so much harder. We have to go to school, memorize the vocabulary. Ultimately, it's how we learn language, the different method. The first is rule-based, or sort of your native language is not rule-based. You observe, you talk. Okay, your brain just wired to talk to your parents, interact, and the parents just say, you said, well, this is a cat. Your parents go, no, 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 that's not a cat, that's a horse. Now you learn it's not a cat, it's a horse. We learn our first language that way. We don't need to go to school. We don't need to remember grammar. When you when you start learning the second language, our education systems just say, here's a set of rules. You have to put the subject before the object. You have to put the verb. These are verbs. You start all those rules, and then you remember all the vocabulary. Ironically, it makes language learning so much harder. So same thing. Early natural language processing used a rule-based system. You teach computers the rules first, grammar. And then based on the grammar, you give them the text, and you ask computer to understand. It's inefficient, and it makes a lot of mistakes because the rule-based system, we know language is inaccurate. Human language is imperfect. It's inaccurate. That's why mathematics is so much more elegant. That's why computing language is so much more elegant. You make one error, it doesn't run. Human language, we have multiple, infinite ways of describing something, right? So it's that flexibility makes it imperfect, but far more functional and far more useful than computer language and mathematics. So the rule-based system had a problem, but later on, suddenly there's a revolution because we suddenly figured out that, hey, maybe we don't need to train computers to learn human language like a second language. Maybe we can teach computers to learn human language as if this is a first language. That's the really machine learning and deep learning paradigm start to happen. Start to train computers, not teaching them rules first, but teach them multiple instances, really, really fast, all of those instances, trial and error, trial and error, trial and error, and eventually they figure out the rules on their own. So it's like teaching kids in the first language. So this comes back at the same time, we start to have a much deeper understanding of human cognition, how human brain processes information. So the introduction of neural networks, especially deep learning, further revolutionized. So we start to make that jump shift. Right? So now we say artificial AI, the term artificial intelligence, the artificial aspect of it is machine, computer science. But the intelligence side of things really comes from human intelligence. Right? It's not just about the robots performing things. At the end of the day, we're trying to create intelligence that's comparable or better or more superior to human intelligence. So the word intelligence is quite loaded if you really think about from a philosophical point of view. What is intelligence, right? Or what's the benchmark? So very quickly, I always like to do this in my presentation because I always want to remind people that without behavioral science, without biological science, without social science, linguistics, psychology, neuroscience, we don't have today's AI. Don't give all the credit to engineers, right? Because essentially what the knowledge came from, say, now we have a better understanding. In the 1990s, the rise of mathematical psychology that paved the foundation to neuroscience, that allow us to understand human cognitive processes using mathematical functions, to understand how our brain cells and neurotransmitters and neurons and neural pathways through simple on and off switch electricity pulse through our neural pathways through chemical and electrical pulse to understand a very sophisticated world. Think, memory, emotions, all these things come from very fundamental building blocks of neural cells on and off switch, and then either on or off. It mimics the computer. So modern computer actually start to borrow from these ideas and start creating neural networks that mimic or at least inspired by how human brains process using an extremely simple mechanism. Neurons fire or not firing. Either have electricity or no electricity, 0, 1 state. But through billions of neurons, we get to process very complex information from visually, cognitively thinking problem in a very higher level. And then we start to build that neural network. The problem of that neural network is computational limitation. At that time, when we start having the neural networks model, mathematically we solve the problem, but the computers were not fast enough. There's parallel processing, there's computer. Suddenly, when the hardware start to process and have hundreds of thousands of computers connecting together, or the chips getting faster, able to process this, now we start creating intelligence. We start thinking about computer networks more like a brain. Right? So all of those, if you're interested, you can actually dive very deep. And then I start to see a lot of papers start explaining, define AI as large language model, deep learning in social sciences. It's important, it's great. But fundamentally, it's the humanness of AI that makes this technology suddenly much more accessible to us. Automation, algorithm, narrow AI existed way before ChatGPT, way before large language model, right? But why suddenly every day my son is excited about AI? Because AI now not only think like humans, not only capable of doing deep thinking and deep learning, but it start talking to us, and it start talking to us like humans. So in that sense, how does it happen? Here's a turning point. This particular paper is quite important in linguistics and computational linguistics. Right? This was a paper that came out 2015 that kind of almost changed everything. That a turning point in computational linguistics, published by the MIT's Technology Review, and then later on generate a lot of work, essentially reducing a very complex, I'm not going to walk you through this paper, but essentially they're saying that how the language space, if we give a mathematical coordinate to each language, at each word in texts, we can, if we represent the relationship of words in a vector space, and then we have assigned numerical and mathematical values to it, even in a three-dimensional world, let's not make complicated things, you can start to actually find some patterns. So the title of that paper is called King minus Man plus Women equals the Queen, the marvelous mathematics of computational linguistics. In that paper, they actually start talking about this idea: if king have this particular coordinate, man is right here, mathematically, if I subtract this, add women, I actually, conceptually, I get the queen. Right? Conceptually, this is easy, but now this is mathematically, we can start to say, hey, maybe language and processing of language can be understood in mathematical terms. The reason it's a turning point is now we can start training computers to think, because now we have numbers, we have mathematical relationship, we have patterns. So without going too much, so that really gave the rise to this idea of we can start training language by feeding a huge amount of data without teaching any grammar. Basically say, I'm gonna keep on feeding textbooks, entire books, right? So the first version of ChatGPT learned 30% of the internet's content, just scrape everything, how people talk, and start to use these brute force to compute this type of mathematical relationship to generate their own understanding and predictions about if I want to say queen, what are the combination of words that allows me to actually say that word? Conceptually, that's a very simple example. So essentially, now we start building large language models using deep learning training. All right, so then you can start talking about all of the technical term. What is large language model? It's just basically large language model is a neural network. We already talked about what a neural network. It's a learning. And what's a transformer? Transformer is computationally, mathematically, we actually make things a little bit easier, more efficient, so that we don't need to spend so much more computational power to train everything from scratch. There's this accumulation. So mathematically, we build these pre-trained transformers and based on the architecture, so that we don't need to establish a learning network, machine learning algorithm, all things. So it's pre-made, right? Just like in engineering term, like a transformer. And GPT is generatively trained transformer, right? So it's a type of artificial intelligence model designed to generate human-like texts. Generative, it indicates that the model is designed to generate texts, piercing together words and sentences in a way that hasn't explicit programmed. In other words, you don't need existing vocabulary. You don't just need to say, the machines don't just say things that's already pre-programmed. It can generate new sentence structures to convey the same meaning, okay? Second, pre-trained involves feeding a model a vast amount of text data so it can learn language patterns, structure, nuances. The process doesn't aim to teach the model a specific task, rather to give it a broad understanding of language. And then transformer refers to the type of neural network architecture the model uses. So GPT, that's why Chat GPT is a GPT being used to understand the chatting, right? You can start using GPT for many things. It's just a technical construct. Okay, so this is the boring part to me. Okay, conceptually, I understand it now. I work my colleagues much smarter doing this kind of work for a living, right? On the north side of our campus. They're developing futuristic stuff. I will never be them, and I'm not trained to be them. I work with them. Okay, it's great, fascinating. I learned that. I can make myself sound very smart to my kids, but it doesn't further my research. Because ultimately, I'm a social scientist, and I am a humanistic social scientist scholar. I wanted to know what is AI to human users. That's what interests me. So right now, I'm just thinking, I'm reflecting on this, that we are going through a period that a lot of us are fascinated by this new thing. So we are studying features, incremental empirical studies that examine specific AI applications in isolated contexts, one at a time, without unifying conceptual framework. We're studying AI's application in advertising, AI in journalism, AI is in education, AI is in this. If you think about this, it's really just saying we are studying these specific applications of AI, one version of AI manifestation in a specific context. Let's evaluate how good it is. Right, that's majority of the work that came out of the last couple of years in social science fall into that category. Critical studies, on the other hand, do the opposite. I attend a lot of the critical scholar cultural studies conferences. You have a full room scholar. I'm not, again, I respect their work a lot, but the thing is they use that AI term so globally, so decontextualized. AI is everything. It's normative. And they just say it's a fixed normative concept. AI is bad. AI is good. AI is going to kill humanity. AI is going to create futures tomorrow. And they have lengthy debates about this. But they say, well, what kind of AI are you talking about? Are you talking about robots, algorithms? There's no nuance. We're overlooking its variability, complexity, adaptability, and evolving nature of the current technology. So without a clear ontological stance, research risks becoming indistinguishable from usability testing. Essentially, we are testing AI products for the industry. We're not generating scholarly work, right? And I'm very critical, I'm very open about this criticism, that all too often, a lot of my students are in information science. They do work for industry, and their dream is to work for the industry and develop systems. But when they join my lab and often talk about, say, what they have identity crisis. What distinguishes a information science student working in my lab using these insights to generate and design better system, and my other half of the student who come from Institute of Communications Research, who are based in social science or humanities, and they're studying the exact same thing, at the end, their paper looks the same. So are we losing our boundaries? Are we truly interdisciplinary, or there's something else going on? So I personally think without a clear ontological stance, we cannot move forward like this, right? We need to start really going back to the roots and start thinking about what is AI to us at the ontological level. So the word ontology is a big word, but really it's a study of being in philosophy, what something is and is not. In this context, it's about understanding what kind of thing AI is, not how it works, okay? The deep learning, the large language model, GPTs, this is how technically it works. But conceptually, what is AI? Socially, relationally, symbolically, how our assumptions about its nature shape our interaction, expectation, and societal impacts. So AI is simultaneously a technical system, a cultural and technical artifact, an evolving infrastructure that shapes and is shaped by our everyday practices. It influences how we conduct research, communicate, interact with media, while it also serving as a theoretical construct that helps us explain and interrogate the very communication process and system it is transforming. And this tension demands clarity on our part at the meta-theoretical level to know what we're studying and why we're studying it. So conceptualization of AI has always been messy. What is AI? We can answer this question. The question is, what is AI? Let's say your grandma asked you the question, what is AI? There's several different ways of answering that question. First way is, what does AI do? Okay, robots, algorithms, doing chores. It's kind of like the machines, making decisions, writing poetries, answering my emails. Okay. How does AI work? You can go into the GPTs, large language models, neural networks. What does AI look like? Robots, computers, smartphone, invisible. How do we know it's there? How artificial is the intelligence? Right? What is that artificial intelligence? If it's truly intelligent, why do we call it artificial? The word artificial is really in relation to human. So there's this anthropocentric, the human-centric perspective to it. Somehow we are the golden standard. Everything else is an artifact, right? That language use is very interesting. So what is our angle of our technical pursuit? Why do we even want to create AI? To mimic us? Cute robots doing our things? I don't care how it works, as long as it kind of act like human, it's artificial intelligence. To better understand human intelligence, I was trained as a psychologist, and when I was in grad school, always we use computers and algorithms to help us understand how neural network work. So our angle is to understand human psychology, human cognition, rather than understanding machine. Machines are tools for us to understand human. Or to increase human productivity and efficiency. It's an engineering problem. I don't care how it works, as long as it performs the task, as long as it automates the process, it works. Or to enhance our human ability to do things we couldn't do, right? To actually have supervision, super hearing, to go to Mars, to go to places where humans can't reach, or in a more scary scenario, to replace humans. So why is this so messy? The messiness comes from the social aspect of this concept. Because AI is not just the technology today. What inspired us to become AI is hundreds of thousands of years of fascination. Okay? Long before computers. In Greek mythology, we already have versions of machines that guards the Olympian. Okay? Generations of just indistinguishable magic and thing. If you really think about what the society we live today, all of us have what we call superpower, supervision, super hearing, instant communication. All these things, if you put in a old cultural sense, okay? I don't know how many of you into these ancient fantasy novels, both in Chinese and culture. All these abilities, we have it. Right? We fly, we talk to each other. I can actually communicate with someone hundreds of thousands of miles away, or tens of thousands of miles away in an instant. All these things are imagination long existed and written in literature and cultural artifacts before these technology become a reality. So the cyclical nature of that is engineers are influenced by these imaginations. They were kids. They read sci-fis. I recently hosted an event called When Science Meets Fiction. I brought my colleagues in computer science who's actually developing these really cool robots. And I brought a professor in English who studies science fiction literature. And I brought a professor in philosophy. We sit together and had a conversation about who's influencing who. Right? What were the engineers reading and watching when they were young, and how that cultural artifact affected their design today, what the system they're working on, and vice versa. The cyclical nature, the holistic nature of technology. So when you think of AI, most of the people, lay user, we did a research, 90% of the people made a reference to something like this. It's not GPT, it's not large language model, it's not network. For most of the layperson, when you think of AI, you either think about this, okay, a scary robot that's going to kind of replace us, or in this instance, and I don't know if you noticed this movie, I'm not going to play it because of interest of time, it's a deeply social, assistant and emotional aspect of it. Okay, so brings back to what I think, and we are working on this ongoing project, that we're trying to start really creating an ontological framework to guide our future research for our own benefit, right? So there are 4 types of ontology that we are, through reviewing the literature and thinking. First is AI as a tool. The ontological nature is instrumental. The analogy here is AI is like a calculator. It used to calculate things, more sophisticated machine. It performs a function. So AI is conceived as a programmable utility designed to perform discrete tasks functioning as an extension of human capability without agency. We use calculator to crunch numbers. so I don't need to do the calculation manually. If you extend that, it's a more powerful version of that. So analogy here is a technical tool. AI as a media system, in our media information system, particularly, I recently had a conversation with Professor Shyam Sundar of Penn State, who had this AI, HAII times model of human AI interaction. We start discussion. I said, well, ultimately, in communication and field of food, a lot of the current work is focused on this. We are seeing AI systems as an extension of the interactive media system. So the roots, the intellectual, the theoretical roots is a media effects root. Essentially, we're going back to say, well, newspaper became television, television became internet, internet now become AI, interactivity increased, features become more, affordances increased, interaction become more sophisticated. So the analogy is moving from TV to social media platform. So you can study agency, perceived agency. You can study property and affordances of these technological systems. So AI is understood as an interactive channel for transmitting, filtering, personalizing information. It's a source of information ontologically, right? It's ultimately in communication, the ontology is a channel of communication. It's a communicative conduit. It's an information source. And analogy is it's a media system. But increasingly, AI is, ontologically is becoming AI as an actual autonomous social actor, right? I don't want to get into the detail of the difference between CASA model, which is computers as social actors, is sort of perception. Like it, a lot of the anthropomorphic features, I feel this non-animated object has personality. This exists here. Increasingly, though, AI is autonomous. It is talking to us. So it's brought from a perceived socialness to an actual social actor. Is this important AI as a social actor ontology? So it's relationship. It's about another being. It may not be human, but it's a being. It's a personal assistant. AI is perceived as an entity capable of engaging in social interactions, subject to interpersonal norms, cues, and biases that frame it as a communicative partner. The subtle difference between 3 and 2 is, I personally, with the space I'm working in, because I'm trained to think the ontologically AI as the second one. But increasingly, I'm start to see AI is functioning, and for all intents and purposes, ontologically, it's no longer just like an assistant. It is actually an assistant. In the field of communication, for those of you who are familiar with that field, we are now really need to start thinking about the value of interpersonal communication and using interpersonal communication theories to understand human AI interaction, rather than studying a TAM or technology adoption model, a rational sort of performance evaluation and AI's information system. Of course, for social, cultural, humanistic scholars, a lot of times we could look at AI as a social infrastructure, because AI is also shaping our behavior behind the scenes. We don't know what's going on. It's changing norms, hidden rules, power structure, right? Institutional. These are things that beyond sort of my research interest, because my research focuses a lot at individual level, but collectively, culturally, institutionally, there's a lot of work to be done there. But in that sense, the ontological nature of AI is a structural condition, right? It's like electric grid. It's like public infrastructure, right? So these are the 4 ontological manifestations of AI. We all call them AI. But I think it really, for me, it helps for me to say, okay, now I can start building theories. I straddle between 2 and 3, right? My intellectual roots, my training comes from 2. I'm broadly aware of 3. So when I produce my research, when I develop my theory, I have a direction. I have a sense of orientation, where I go, what kind of theory I will select, and where do I go for my literature review. So I will not get lost by the hundreds of thousands of research articles. We did SSCI research. Take a guess how many articles have a topic of AI and keywords of AI in the last 10 years in SSCI index journals. SSCI has about 3,000, over 3,300 journals. 492,000 articles just in the last 10 years about AI that has AI in a keyword. The space is much bigger than we think, right? But when the problem is, this is sort of sidetrack a little bit. At one point, oh, I'm out of the frame. Okay. At one point, when I went to grad school, we go to the library. Our literature review stays in the field, sociology, psychology. Today, all of us use Google keyword. I've been trying reteaching my student how to use library because Google is keyword based. We have no idea whether you Google keyword, you're going to get a collection of articles from medical journals, from psychology, from engineering. We read it, read the abstract, and we start citing them. And that's why I think our field has become atheoretical by the day, right? This is my bitching session. Now I'm going to move forward. Anyway, very quickly, I'm using up a bit of time. Very quickly, I walk through some research. Since I'm going to be here for a while, I welcome you to join me and talk about this. So this is not a presentation about our research, just walk through a couple of topics. So these are ongoing. So I'm going to introduce 3 ongoing topics, projects that we're actually analyzing data under journal under review, and then we're going to share some publications. So the first project, about my lab, it's just an interdisciplinary group of people. My students, half of them come from information science, couple of them from computer science, and then the other half, majority, come from social science and communication. So we work together. We have a shared interest. The shared interest is media technology and social behavior, very broad topic, right? So interdisciplinary exploration of interaction of technology, society, human communication. Our first project, going back, I was talking increasing, even though I was trained as an empirical quantitative social scientist, I had the fortunate experience to have enough breadth in humanities training and qualitative brain training. So our first study is really a mix, kind of we just wanted to know, right? I don't want to make any presumptions for me to define AI. I really want to know how laypersons think of AI. So we did an interesting study, okay? We collected 219 valid open-ended responses, one question. It's a questionnaire. But just simply say, when you think of AI, what comes to your mind? Open-ended, fill it out, okay? We analyzed this data set, just one question. It's actually two parts of it, but really that one question yielded enough finding for us to actually try to publish it. So it's currently under review. The idea is just that one question. We created 3 different ways of modeling it. One is just simply categorical, creating a grid. Okay, we coded the response, human coded along 3 dimensions. Is that layperson's first mental representation of AI, what they write down? Are they referring to an embodied or disembodied entity? Does that intelligence have a body? Is it a robot or something magical? Second, is it human-like or machine-like, right? Do they use metaphor, the language used, do they kind of, it's my assistant. It's like an intelligent person versus it's a machine, a computer, like a calculator. A third dimension is it tangible or intangible? Meaning that a lot of times a virtual assistant may not have any manifestation. It's like an algorithm working behind the scenes. But tangible is there's an application, like ChatGPT is tangible, but disembodied. Okay, that's a technical distinction. So we start to see some archetypes. And we also did some cluster analysis, running through the models. But idea is that we start to see 6 distinct layperson or archetypes. Invisible mechanism, right? Disembodied and functional. Ghostly companion, disembodied social actor. But then after this, we revised this. We just basically found that, sorry, this slide is a bit outdated. It's preliminary finding. We submitted this paper. It really converges on 2 very intuitively things. It's just converging two clusters. One cluster is have some sort of personality, human-like, could be an algorithm, but the personification aspect of it. The other is very just machine-like, whether it's embodied or disembodied. So after all the 6 archetypes, really when we look at the cluster data, humans think of AI incredibly just these 2, almost evenly split. Half of you think of AI as this social-like thing, okay? The others of you think of it like a machine. That's it. And then we, of course, have some data, like expectation of performance and so on. But we talk about this. The second project is really extension of this project. We wanted to know, does this mental representation, okay, when you think of it, AI as a human-like or machine-like, does that affect your communication style? In this instance, we're very interested in prompting, not as in prompt engineering, but we look at linguistically, going back to the classic theory, looking at prompting as a speech act. Okay, 1969 Speech Act, meaning we are essentially using language to tell AI to do things. But human language is very imperfect. If I use a machine, so when I use a mouse to interact with my computer, I click on this, I click on that, I click on this, it will always produce the same output. No matter how many different combinations if I do the search, the output is the same. The problem with human AI interactions depends on how I articulate my problem. The style of my communication, am I a assertive, bossy person? Or am I the sort of like very polite, can you tell me about something? It changes the AI's output. It generates different output. So this is move AI beyond a machine, because machines has to perform reliably. No matter how many times no matter in different ways I interact with my computer, the performance should be consistent. In this case, you have no idea why AI produced that version versus that version when you ask write an essay, right? So we think that the most appropriate way to study prompting is going back to the basic communication theories and linguistic theory to look at it as a speech act. So essentially, we're looking at it as a conversation. So let's see an example to illustrate this. Same scenario, okay? Taking my family to vacation, planning a trip to go to France. This is the actual response. Create a travel itinerary for a 2-week trip to France. Commending, I'm telling the computer to AI to give me a very specific output. Right? Direct language. This is the AI response. You asked for a travel itinerary. I'm going to give you a travel itinerary. Day 1 arrives in Paris. It's very direct. Exact same scenario. I changed the prompt. I am planning a trip to France. Can you help me create an itinerary for a week? In this case, it's a question mark. I don't know what I'm asking you. I'm not telling you to do something. I'm giving you permission to be creative. Now, language, my colleagues in the computer science side of things, like it's just fluffy stuff because it doesn't change but my argument with that, it doesn't matter whether or not the algorithm is the same. The output is different. The output is AI is answering you a question now. Linguistically, it's sure, I'd love to help. Are these specific cities or attractions you're interested in visiting? Now we're having a conversation instead of a calculator giving you output. So now it gives you agency, right? It's asking you for input. I'd like to spend some time in Paris. Great choices. You can say all this is fluffiness. At the end of the day, it's just spitting out some itinerary, but the human experience is fundamentally different here. Third, let's work together to plan my 1-week trip to France. I want to visit Paris. What do you suggest? I'm giving you some parameters. So these 3 versions is our research is trying to say that perhaps somewhere between we think AI works this way, we expect a perfect answer every time, to I have no idea what's going on. Whatever you give me, you're guiding me, to a collaborative model. I'm going to give you some parameters, but I give you enough flexibility, enough agency to actually give me some suggestions, but I'm in charge of evaluating those suggestions, right? So from a communication and dialogue and conversation point of view, this is an extremely rich data set to analyze. But from a computer, if we just looking for large language model, this is kind of a pointless, right? I still have disagreements with my colleagues in engineering. So this is another paper that's under review. We're looking at the minds behind the prompts, how mental models shape their interaction. And it's, so we did some user clustering. I just wanted to, this is boring stuff. We'll talk about it. Let me see. So key insights, mental models shape how we engage with AI, highlights the need for adaptive, right? Just give you a 1 sentence. Project 3, this is sort of a personality AI co-creation. We just presented this paper at CHI in Tokyo. I mean, not in Tokyo, in Yokohama earlier last week. So looking at, so this is from a student. So the first 2 studies were led by students in communication. So we're interested in communication process. This project was led by a student in human-computer interaction in CX design, UX design. Okay, so she's a designer. She's very interested in saying, well, okay, knowing all of those, joining your lab, ultimately her goal is to create an AI writing companion to help people write, right, in a more structured way. So she's very interested in human writing agents, so that we keep on designing these AI interfaces to help people write. She's very interested in how personality affects this, right? So she wants to design a system that adapts to the user's personality, okay? So she's fascinated with this, and it's a really cool project. So basically, she say, well, can we create an AI conversation style and companion, writing companion, that reacts and caters, then accommodates the user's personality type? And this is a user research, qualitative interview, typical sort of human factor and user. So how that improves the experience of using the system and also the writing output. So this is the first of a serious study that we looked at research, the sort of design question one: what functions could writing companion have to assist users in writing? What are the functions do they want? And second, what type of personality could a writing companion have to facilitate engagement? And design question three: what would be the visual embodiment of a writing companion look like? So we, based on these three questions, we interviewed users, 24 participants. We really pre-screened them into out of the 16 personality type of MBTI, we kind of selected 4, okay, and 6 per group. So considering grouping, age, gender, and others 2 MBTI dimensions, and an introduction, writing style experience, typical writing process, steps. We have given them a flow chart, sticky notes, companion role, introduce a lot of the design features, and then we qualitatively recorded what they think about these features and what they want. A snapshot of finding that personality does make a difference. Different personality type want different features, right? That's the takeaway point. In other words, if you are a sort of NT side of things, you will want persona features, chat organization. You want to have dialogues. But you're a TS one, you provide reasoning. Let me explain to me why you want to edit this paper this way, right? Language writing. And an NF sort of emotional appeal, right? Wanted to visual interaction. And an SF is sort of actually much less. So we start just in this limited, we start to kind of see that pattern. So our next step is to actually prototype this and then get a larger user study so that's a first step, okay? So companion's personality, NF prefers a friend, ST prefers a tool, SF and an NT performs one warm function, right? So this is, again, gives you an insights of what people actually want the experience to be when they work with AIs. Okay, so this, okay, go ahead. So a few other related publications out of our lab. We dabbled into how gender identity influence human-machine communication. This is a paper published a couple years ago. Essentially, we're looking at, do people bring gender stereotypes when they interact with AI? So we experimentally manipulated the gender identity of an AI assistant, and then we evaluate, do they trust it more? Do they perform it more? But the finding is that, yes, we do. Gender doesn't affect it. In other words, we actually bring our own gender stereotype into human AI interactions and performance. So we are, like it or not, whether it's an algorithm, large language model, ultimately users unintentionally or intentionally, consciously or unconsciously, are bringing out existing implicit biases into these scenarios. And then that changes expectation, trust, credibility, and output. Another paper was recently published looking at conversational internet search moderates search-induced cognitive confidence. This is a paper that we follow up on a well-known, well-documented empirical finding that the more people use search engines on their phone or on the computer, the more we inaccurately think that we are smart. We are not that much smarter. Just because you can search something right now, an answer, it doesn't make you smarter. But because this device is an extension of our cognition, because this device is with me and I paid money for it, it makes me walk around like I feel very confident. I'm the smartest person, right? But we found that that conversational interface mitigates this effect. Because now I am no longer smart, because it's that persona, the other person or other entity, that's the knowledgeable one. So in this experiment, we look at a conversational interaction versus simply using a phone, right? And then we measure that in the consumer context. And finally, we recently extended to somehow justify my affiliation at business school. We started to do a lot of these kind of consumer behavior related. So we basically saying how we explain algorithm in AI to the human user, how we frame AI work, and where the source of that intelligence come from, sort of explainable and transparent AI affects our decision making. Okay, so this is a little bit more technical, so that's why it's peripheral related to that. But what we basically found is humans still prefer human intelligence. If we say that somehow magically there's an algorithm, it knows exactly what kind of wine you like, versus we studied other human users based on that collective insights, we decided that you like this wine versus based on your own previous behavior. Okay, these are the three type of framing. We still prefer the human intelligence. Okay. So across all these studies, human performance and psychological processes such as language use, personality, stereotyping, expectation, attribution of knowledge play a critical role in shaping how we perceive, interact with, and use AI technologies. This foundation invites us to explore how our perceptions of AI influence our engagement with it. Okay? So even though they across different domains, so the takeaway point, and I'm going to end my presentation here, is that we don't just interact with AI, we actually relate to them. This is about relational building. It's about trust. Ultimately, how do we grow to trust a system? If I were to evaluate a product and a technological product, how it works is its reliability, performance, accuracy. Half of the room are still actually doing that. That's why we say AI is dumb, AI is smart, AI is good for this, AI is good for that. But as AI start to behave and talk and exhibit human-like features, and not only exhibit like human-like features, but actually start to talk and autonomously and act autonomously and making autonomous decisions, at least half of us, based on our mental representation, we are building trust and relate to them. And it's about a much more genuine relationship building, self-disclosure, companionship. And then OpenAI released a large data set study out of its lab. Surprisingly, a growing number of people, even just with ChatGPT, they start to see a very specific but growing percentage of users are using it as social companions. Loneliness and talking it out loud because they find that ChatGPT listens and it replaces so many companions. So we start to see that divergence, and I'll leave with that. And thank you.
Thank you so much. We've learned so much from this talk. I can't say how grateful we are. And so questions and comments, feedback. Yes, Ming Ming and then Yang.
Thank you. Thank you for an interesting talk. So it strikes me that starting with your early question about why do you expect machines to be perfect and human assistants not to be, I think it comes partially, I was thinking about this, I have a couple of answers. So one is that let's think about a doorknob. You turn a doorknob, it opens, it's perfectly reliable. I mean, it's very rare for a doorknob to break down. And part of it's the simplicity. It's a few parts, it moves, it works fine. And so it actually wasn't true like this 100 years ago. A lot of machines broke, a lot of things didn't work. It's actually, we're in this rare age where we have sigma 6 quality where 1 in a million things break down. So in our current experience, most machines or objects work fine. They work almost 100% of the time. And so that's probably why where it comes from. And I was thinking about this because I actually have the opposite intuition. Like, I'm a statistician, so I expect everything to break down. Everything like doesn't work some of the time. And so I think like most people are not like me. I'm just a weird person. But I think most people do have the expectation machines work, basic objects work. So that's all reliable. And humans are really complex. And the complexity is that's why they're not reliable. They do things differently because they can do so much more. And now we have something like a peer where artificial intelligence is amazingly complex. And so what humans try to do is like we try to use our own experience, or we try to make sense of things the way we do. So like when you gave that result of like humans perceive AI as like either machine or as a person, well, that's what people are used to, right? They use machines, people, and I think that's actually kind of a good thing. Like we don't understand this crazy complicated thing. Let's try to use what we know. So when I interact with AI, I interact like a person. I use information about interactive people, and it helps me interact with AI better. And likewise as a tool, and that's good for things, bad for other things. And so I'm surprised your computer science colleagues, think of this as like fluff because like the way AI works is that it's using the input we entered, the prompts, used information. So if we have like a conversational style, it's accessing things that are conversational style type stuff. So of course AI is adapting this because like that's the way it's supposed to work. So I think like the bigger issue here is like about complexity, where now it's something sufficiently complex, introduces all things that we have, the same problems we have human beings we now have with AI. Like it's so complex, we're not sure what's going on, it's not reliable, and those are both good and bad at the same time.
No, I appreciate that comment a lot because I think, I mean, to clarify, I don't think my colleagues are truly think it's fluffy. Otherwise, they wouldn't work with us. It's tongue in cheek because we're friends. It's always that who gets the bigger grants, right? Social science grant, the exact same topic. If they present it, they get millions of dollars. If I present it, I get $20,000. Like I'm very happy. So ultimately, even very intuitive human side of things, we have to present it in very sophisticated mathematical equations just to kind of make it work. But really, more seriously, I think what you mentioned is that it really struck me. One of the most sophisticated system is human brain. But very rarely we ask the question how it works because it just works. We don't actually think about, more familiar with the visual system. It's extremely complex. The lights coming in, the eyeballs and the nerve system and processing and then how we make sense of these things. But it just works. And I really appreciate, I think the technology that we are coming to a point where the intelligence part, that's why it's scary and fascinating because our modern technologies are becoming that reliable, right? I don't need to know why AI works. It just works. It helps me to do these things. It's both a exciting time, but at the same time say, well, what if happens that one doorknob today doesn't work? We only notice technology when things don't work. And so that's another very interesting thing that you mentioned. For me, what fascinates me is a sort of a personal intellectual curiosity, right? Is there a switch that our evaluation system switches? To me, I don't think it's a continuum. I'm increasingly confident to say that our evaluation system of how do we evaluate something work or not, there is a utilitarian functional perspective, even when we think about people, and there's the emotional relation aspect of things. But there's surprisingly, because of the cognitive revolution, there's surprisingly thin literature in comparing cognitive to understand the more emotional, intuitive value that it's valuable, but you can't articulate it. We were talking about that, right? We start thinking about quantifying every aspect of human behavior in a job. Your job, like a doctor's job, is how many patients you see. But the value of a doctor is not how many patients you see. It's the invisible value, the inherent implicit value of treating the disease. But because of the quantifiability, the quantification aspect of it, we have to reduce all of those into numbers. In that attempt to quantify everything and represent everything, we're losing that very important aspect of, but no, my doctor is more than just the doctor spent 5 minutes with me, answer 3 questions. My nurse is more than just delivering the medicine 3 times and move this patient from this bed to that bed 4 times. There is the inherent value we use to evaluate the difference between a friend and a collaborator. If I work with a collaborator, You don't deliver on deadline 3 times, you're out of my team, right? If in a company, my assistant makes 3 mistakes, you're gone. If a customer service representative answered a question 3 times wrong, you're fired. We do evaluate humans that way, in a very utilitarian way. But flip side, if we think about it, my friend, who's also a collaborator, can flake out, miss meetings, and do not do the deadline. But guess what? I like that person. So I'm going to work with this. How do we quantify that? Right? These are the kind of things, ultimately, I do think there are 2 distinctive evaluation systems for humans to evaluate things. And I'm increasingly fascinated by that construct of value. Like, how do we value things? Is it quantifiable? To what extent this is a rational choice, or is this irrational emotion, gut instinct? And I think in the context of AI human collaboration, it changes a lot, like how much aspect I give to this human. Sorry, it's a long-winded one.
No, that's helpful. Thank you.
Yeah.
Yeah.
All right. Thank you, Professor Yao. I really learned a lot. Thank you for this genealogy of AI. That's really amazing. I just want to say that about the ontological shift, the work that we are doing now really aligns with what you're proposing. I think, especially AI as social actor and also AI as social infrastructure, because I come from sociolinguistics and anthropology. So we look into those individual level of interaction, but also the structural power. And one thing that we are doing the project is that to kind of theorize AI social actor. We use, like you said, if we have this ontological shift, then we know what theories we're going for. So we went to sociolinguistic theories, like interactional sociolinguistics, which is very kind of have some overlap with your project too. So I'm very interested. But my question, maybe not a question, is like a thing asking you, what's your opinion on this? So we developed this framework, and then we submitted to a very prestigious AI conference. And one of the, I think it's rejected. And then going through all the reviews, the reason why it's rejected, I think the key reason is that it says it's lack AI methodology. For my understanding is that maybe it's talking about technical, computer science methodology. So my question is that, okay, so when we try to use theories from communication, from sociolinguistics to do research about human AI interaction, I think collaboration with computer science is very important. I just want to know what's your opinion on this? Do you have experience or suggestions on this, in terms of methodology?
I do, but those are my opinions, and it's very loaded. I do think that going back to, we have to be pragmatic and idealistic at the same time. I think that's the beauty of being Asian. I work within a multicultural environment, right? So extreme utilitarianism is a tendency. Right? We need to get tenured. I need 18 papers, and I need this many impact factors. I don't care. I'm just going to go through my journal and sort them by impact factor, and then just go. Get rejected, second one. Get rejected, second one. I'm coming to an age that I would tell my student not to do that, but at the same time, I have to be empathetic. If I was born, if I'm a graduate student today, I'll be shitting my pants because the competitive environment is very different. So my short answer, we can talk a little bit more about that, is don't lose sight of what you truly want to do. But kind of separate your research into, this is something too important for me to sacrifice and cater to the reviewer's comments. Find a community, find a group of people who is willing to listen to you. You will find it, because that's your home. You don't want to leave. As interdisciplinary as you are, don't leave your home. This is your home base. These are the people you have talked. The other is really about practical, like how many papers you need, but we'll talk more.
John.
Great. Good to see you, Mike.
Yeah.
This is very, very good, what you've done. Sorry I came in late because I had to run from another meeting. from another campus had to come. Anyway, so you know, the jump from just looking at applied AI research into looking at ontology is brilliant. So here's a question about ontology. So you listed several ways in which we can find that orientation. My question is, given you know that increasing productivity is such an imperative in our relationship to AI and our use of AI, would you consider economics or anything economical to be ontologically important and foundational to AI, given that our urge to increase productivity using AI comes from classical economic transactions. It is transactional. It is about increasing the value. It is about throwing out certain value through my prompt in exchange for another higher value from their response, et cetera, et cetera. So it's an economical ontological relation. Now you have a business affiliation with business schools, so I think you can answer that question, okay? The second question is this. You know, I think all of us are, you know, besides being fascinated by this, of course, you know, from the social science humanities side of things, which I am like you with that background, you know, I have a lot of sympathy for the kind of paradigm that you're building. I think you're building that paradigm, which is just so brilliant that, you know, you put in all the theoretical constructs that can help you build that generates that ultimate kind of insight that it's really about relationality. Okay, that just to summarize very grossly what we've done. Here's the question. But just as you build that paradigm, other people from other disciplines, just like your computer science colleagues, they're also building an equally intelligent, equally valid paradigm. And maybe there are a third, now it's so binarized, but I think there could be a third or a fourth position in this. So at the end of the day, what is the meta reality that we're going to face? Can you speculate out of these? Because you're right and they're right too. Yeah. And of course, you know, it comes down to who's more right. I think that's a valid question about who's more right. But there's a deeper question, whether you're right or not, or more right or not, has a greater social impact on how the world is going to move into the future. Yeah. So there's the meta question here. Anyway.
Oh, that's I love to have that conversation with you more deeply, because that's why I said I'm becoming an amateur philosopher. I've always interested in philosophy. I think those are the questions that really hits that core. But going back to this one, so the economic part of there's the macroeconomic. It's not an answer. That's my opinion. So there are two ways I'm thinking about it. One is the actual mechanism of economic, right? Because I could tell people, like, you can hate AI all you want. There are trillions of dollars being there and driving and designing, and it's called capitalism. And then you can, I mean, I give a lot of talks. I mean, this is, sorry to a long-winded answer, but you know, it's okay. Sorry, apologize for the long answer. Our campus is set up that the north side of the campus is all engineering, like sci-fi stuff. Yeah, you're from that campus, yeah. So the south of the campus is sort of the more humanities and stuff. So the distance between north and side of a south campus is actually probably 3 kilometers, 4 kilometers, right? It's take a while. The ecosystem, how it works is the engineers work on some technology. They occasionally, these technology being adopted by the industry. The industry create a product. The product being used by human users. It takes 10 to 15 years for the critical cultural scholars to go, wow, this is so bad. Why can't you walk that 4 kilometers and start to have that conversation? That's the reality on campus, right? We're in the same space, we're in the academy. This is so frustrating for me, who actually occasionally travel, I mean, every day travel between these strata. So going back to that, is like, there is an economic reality to it. The economic reality is AI is it used to be that a technology, for it to take shape, takes decades. Then the last few decades takes a couple of years. Now we're talking about a weekly. Things are changing. And I don't know. Honestly, I just feel that I'm increasingly jumping on the soapbox and say that humanity is probably the most important subject matter. And because you know me, I'm sort of in between social science, and I really think that we have so much technology. There's ample technology. Really, the meaning of what it means to be human is the question that's more fundamental than anything at this point. But I honestly think that my pessimistic view is the decades of education of separating these artificial STEM and arts from very early education has now manifested a detrimental problem. That is, I can no longer find engineers who can actually talk about poetry with me. I've talked about some, this is a personal experience. I used to be able to find like, so I'm in between this age group. Some of these professors over at engineers, they love music, they love poetry, they just happen to be engineers. Now I'm interacting with people, they don't even read poetry, they don't even read news, they have zero interest in this. And they're in their lab 20 hours a day, imagining a problem and solving that problem. I don't diss engineers, but I say that to them and I said, you can't imagine a problem and create a machine to solve that problem. Can we talk about, I know the problem, you have the solution, can we talk about it, right? But it's hard because of the grand application that's economic. Second is individual level value. Individual level value, I do think that this is short answer to a question is observe your own behavior. I observed how my behavior shift even with you, even using ChatGPT depends on the task. I changed my communication style because I used to say that if I wanted ChatGPT to edit a paragraph and check my grammar, why do I want to be polite to it? But late at night, I'm brainstorming something. I actually sit very differently, but it's the same application, right? So I do think context matter. Communication fundamentally, going back to our field, fundamentally communication is governed by context. That's why we have interpersonal communication, intergroup communication, mass communication. And then modern digital communication system collapse those contexts, right? We don't distinguish that anymore. There's no more mass communication. Social media is everything all at once, right? I think it's time for recontextualizing things and then to bring back context into value and context are the two things that I'm very, very interested, spend a lot of time thinking. And I think we need to build those theories around that.
Thank you so much. We have to leave this classroom, students waiting, but we have a fresh conference coming up and details will be given to you. So let's put our hands together to thank Professor Mike. We have all benefited from your insights.